Greetings and welcome to Math Friends, fellow friends of math. Today we will be graphing the derivative of a function. Now, to start off, I'm going to draw an xy plane, which I'm sure you have seen numerous times throughout your math careers and probably have grown to hate. However, today we are going to love it because we are friends of math. Here we have the y-axis, and here we have the x-axis, x, y, and I'm going to draw the function f of x. That function will look like this. And we are going to graph the derivative of this function. Now, a general rule of thumb when graphing the derivative is when your tangent line is horizontal, or the slope of the tangent line is 0, you can put the derivative dot on the x-axis at 0. Now, from this point to this point, when we draw our tangent line, if you look anywhere we draw this tangent line, the slope of such tangent line is negative. So, I'm going to draw a point down here in the negative. Now, if we go from this point to this point, anywhere we draw our tangent line, it's positive. So, I'm going to draw a nice little dot up here on the y-axis. Now, when we go from this point to this point, the slope is negative. So I'm going to draw a dot down here. And now all we do is connect the dots to see what the graph of the derivative looks like. This is really poorly done. Big dot. And if you see it, it is an upside down parabola. And this is the derivative f prime of x of this function, f of x. Let me show you a couple more. Erase this. I'm going to draw another xy axis. Y, x. I'm going to draw f of x. And that function will be a little different. It's going to look kind of like an M. Go up, it can curve, go down, and curve again, go up, and come down. And we're going to graph the derivative of this function. So, again, using the general rule of thumb, tangent line here, here, and here, the slope of the tangent line is 0. So we can draw the derivative point at 0. Now if we were to draw the tangent line from this through here, anywhere along this, the tangent line will be positive. So if I just say draw one right here, the tangent line is positive. So I can draw a nice little dot up here. Then if we go from this point to this point, anywhere I draw this tangent line, it's negative. It would be negative. So I'm going to draw a point down here. Now as we move from this point to this point, anywhere I draw the tangent line, it will be positive, going up. So I'm going to draw my tangent line right here. And then from this point down to this point, anywhere I draw the tangent line will be negative. So I'm going to draw a point down here. Now, we get to play my favorite game, which is connect the dots. Connect these dots. Again, I missed the circle. And this blue line right here, I don't know how you can see it, make it bigger, is the derivative of the black line, that function. I'm going to do another example. This one's going to be a little tricky. So if you think you've mastered it, hold on one sec as I show you another example. Again, we're going to draw our favorite two lines in the world, the y and x axis. axis. And again, I'm going to draw the function f of x. And it's going to look a little something like this. Now, the first thing you need to know is that when you see a sharp curve or a point in the function f of x, the derivative cannot exist. And so here and here, anywhere along here, the derivative does not exist. So you might say, well, how are we going to graph that? Well, since this is constant, the slope is 0. And so I'm going to draw an open circle right here. I'm using red this time, just because I like this problem. And slope, since this is constant, is 0. So then I'm going to draw it down here. And here it's also 0, or it doesn't exist. So slope is 0. And then, so from this point to this point, 0. From this point to this point, 0. From this point through, 0. And this is derivative of this function. And it's important to know that you can't graph the derivative. You can't graph the derivative of a jerk or a sharp curve, or a sharp curve. As if it's a jump, or if it's a jump, or if it's a discontinuity.